This has always been a bucket list item for me, presenting at Ignite. And then in this room, so glad you made it for this, this one. And of course, the bucket list item was successfully presenting a session. So fingers crossed. Hopefully we'll get there, but I think we'll be okay. I'm Roeland. I'm a cloud architect and an Azure MVP. And I'm very happy to present this session together with my good friend Eduard.
Yes, thank you everybody for being here. My name is Edward van Valkenburg. I'm a senior AI cloud solution architect in the Microsoft Netherlands organization. So I work with customers with OpenAI on a daily basis, and yeah, hopefully we can show you some really practical stuff, because I think before at the keynote they talked about all of the new stuff, all of the cool demos and everything. We're going to make it super practical and actually build something that works.
We're going to make this real, yeah, so that's very cool. And that is one of our challenges, because this session and the underlying project, there are so many cool things. There's an amazing Blazor front end. We have CI/CD from GitHub. We have code spaces integration. We have dev containers in there. But of course, OpenAI integration and Cosmos DB as well. So we're really going to try to do justice to the title of our session and really stick to those OpenAI and Cosmos DB parts. But feel free to check out the rest, and more on that later. Thank you. So what are we going to look at? We're going to look at integrating OpenAI in our chatbot, in our Blazor front end, wiring it up. We're going to look at the OpenAI playground in the portal. We're going to look at prompt engineering. We're going to look at model parameters. And of course, we're going to wire it to Cosmos DB for our data persistence layer. And then, as a cherry on top, we're also going to show you how to leverage your own data in your OpenAI instances. And for this project, what we're going to show you, a dramatic pause. Our development team has created this amazing Blazor frontend, which is perfect, but has no functionality as of yet. So we're trying to integrate conversation history to add some data persistence, so you can resume chat sessions, so the messages are stored, so you can rename them, can delete them, and so on. But especially using OpenAI to interface with a large language model. But for now, we only have the app service, so the Blazor frontend. So that's everything within the blue dotted line we currently have, and we're going to implement the other stuff. So we're going to implement the yellow rectangles. We're going to start with OpenAI. Eduard is going to show us all about that. I will try to interface it with Cosmos DB so our messages are stored, and then we end our session with bringing your own data and how to use that in the OpenAI. The best thing about today is, of course, the content that we're presenting you. It will be a very nice session. But the amazing thing is you can do it yourself as well. So that's a bit of homework for the holidays. Christmas is coming up. Maybe you have some time at your client between Christmas and New Year's just to fill the void. So you can try the lab. There's an amazing lab. The link is on the next slide. We'll share it there. And we'll definitely share all the links at the end of the presentation as well. So if you miss those links at the end, we'll show them again. But if you don't want to spend time with your relatives on Christmas, you can also do this lab. So you can do all this stuff yourself, but of course you're going to need OpenAI access, which is kind of important because it's the beating heart of our system. So that's a link at the right bottom corner. You're going to need to request OpenAI access for your Azure subscription. And I've seen it take minutes, I've seen it take days, so be there before you want to start with it. And do it a couple of hours earlier, so you definitely have access to that amazing OpenAI instance. On the left, if you've never used Azure before and you're still up for your trial subscription, you can use the link at the bottom left and you get a starting credit of $200 to get started with Azure and the lab we're showing you. We, of course, have to deploy our resources as well. And this is not, we're not going in depth. We promise we're going to stick to OpenAI and Cosmos DB. But we're going to touch upon that just to get it out of the way and to get you started, if you're going to do that lab, to actually start focusing on the important stuff, the OpenAI and Cosmos DB things. And there's an amazing zero-touch deployment bicep template in there to deploy all your resources. And if you're familiar with the CLI, you can definitely use the Azure CLI. If you log in, it's just one statement that is in the lab as well to get you started with your resources in Azure. But if you're not familiar with the CLI, we have it even easier. We have a deploy to Azure button on that fork of your repository. The repository link in the previous slide, we'll definitely share it at the end of the presentation. And you just click the button, and it will provision it for you. It is somewhat easy, and of course, you're now going to say, but Roland, friends don't let friends right-click publish, right? And this really feels like almost right-click publishing. Well, in this case, it's okay, right? Because we're using it for a lab, and we just want to get started with OpenAI and not be spending half an hour to get started. But that takes 5 to 10 minutes, and of course, we did that beforehand. So just to move ahead with a demo, because I think these were our slides. We are now only demo, so hopefully everything will work. And Eduard, can you show the not working application as we have it now?
I will. So we're now going to switch over directly into our project. So it's a .NET project, Blazor front end, then some services to connect to OpenAI, to connect to Cosmos DB, and we now need to have a look at what we need to do. So let me get rid of this. So the first thing that I already did, because it's annoying, is to include some packages in my solution. So the most important one is this one, the Azure AI OpenAI package. So this is a .NET package to connect with OpenAI to kind of abstract away the fact that you need to call a REST endpoint and do all of that stuff. So we just bring it in. And then here in the OpenAI service, this is what we're going to implement in a second. So the app already runs. So I'm just going to press F5 to actually build it and run it. So in the back, let's have a look. It's now building the project, opening it up, and in a second here you'll get a website.
About 6 people have told us, your demos will be okay. Nothing will happen. Nothing bad will happen. No special characters suddenly in there.
So it's rebuilding now. Give it a sec. There we go. Now we should be loading the website here. It's on my local host, so it's just running off of Visual Studio Code. Yeah,
and
here we go.
Works.
So we now have our front end. I can now do a chat, but as we will see in a moment, we now get just a blank response and also just not a actual summary of the conversation. So this is our starting point. So now we have a running web application. We have some placeholders in here. So now let's start actually thinking about, okay, what kind of chat app do we want to build? For that, I'm first going to go over to the chat playground. So once you have Azure OpenAI deployed, you get this playground where you can actually start experimenting with different prompts, with different parameters. And so the first thing that you see here, and this is the big difference between you going to like chat.openai.com, just using ChatGPT, is that you can actually, although they have some stuff in there now, but you can actually define the way your bot will respond. So I can adapt the system message to be whatever I want it to be. I can give it a different persona, different tone of voice, different ways of responding. So currently it just has a very basic message in there. You're an AI assistant that helps people find information, provide concise answers, polite and responsible. Now, the other thing to note here is that we have some parameters that we can set. I also choose a model, so in this case I'm running against GPT-4. And I can define how big the response is allowed to get with this max response. I also have this parameter called temperature, and that basically controls kind of the randomness of the response. Between 0 being the least amount of randomness and actually 2, but in the portal only to 1 to get more randomness. I'm going to start it off at 1 and just see what it comes up with. So let's just introduce ourselves. Just to see if we have a working connection here to the model. So it comes back. It sees my name in there. So it says, I'm an AI assistant, and we go from there. So let's get the actual our actual private bot to do the same thing. So back into code. So first I'm going to have to make sure that I use the OpenAI package, because otherwise I'm not able to do that. And I also need the Azure package to get credentials. Then I need to add my OpenAI client into my class so that I can interact with it. And I want to add the string for the system prompt here so that I can easily adapt and change it. So let me go here, grab this one, and I need to add an end line to it, a new line. And here we have our system prompt now stored. So now we have the placeholders for all the stuff that we need. So now we're actually going to build up the client. So I first need to parse the endpoint that I get from my settings into a URI class. I then need a key credential with the key. There we go. Before I forget, I need to actually make sure that I capture that model name that is coming in as a parameter. So now I've captured all of the parameters into different things, all but the actual class. And for this one, I need the URI and the credentials. And that's what I need. I now have a client in my class that I can use to perform calls to the OpenAI endpoint with. Now, in my app settings, I have an endpoint, a key, and a model name set up. That is being used to connect now, and of course these become part of your whole deployment flow with app settings and all of that stuff as you build this out. So now we need to implement the method that gets called whenever we type something in the chat and press go. So here we have the blank response that we just saw in the website. So we need to do some work here. So the first thing is we need to actually construct a message out of the prompt, which is a system message. And we add system prompt. Then we add the user prompt. The user. And for the keen observer, I have GitHub Copilot running alongside me, so a lot of this stuff is being auto-completed as I go, which saves me a whole bunch of time. So now I am creating my options. So I'm creating an options to grab all of the pieces that I need, all my parameters, my messages, all of that stuff in a object that I can then stand off to OpenAI. So this is so these are my two messages that I need. Then I have some other settings to set. So the temperature, let's set it like 0.3, so a bit of randomness, but not too many. I have a session ID that I'm using in order to keep track of what is going on and be able to use logging and other things there. Oh, this is it doesn't like this, so let's make this user message. Max tokens. So, and here we have our options. There's a lot of other stuff in there, and you can experiment with that. But for now, this ought to do it. Next, I'm actually going to do the completion. So we're going to use the client that we created. It's going to be asynchronous. Oh. Chat completion async, and I'm going to give it the model name that it's using, as well as the options that we just created. So this, once it runs, gets the actual response from OpenAI into a class. And then I just need to craft my return statement, which is a tuple of the completion text and the tokens that it used. So the completions text is... choices. I'm just getting one response. And then completions.usage. And there we have the class or the method to get the chat working implemented in real time. So now we're going to restart the app. So hopefully I did it correctly. Looks like it's building. There we go. So we're running the actual site now. This always takes a bit of time. There we go. So now when I start chatting, we now should get a response. So it's saying, when I say, how are you? It's saying, I'm a computer program, I don't have feelings, go away. Which is expected. So this is a good first start, but we still see this the summary up here, so we need to do some work on that one. So that's the other message, or the other method that we need to implement. So that's the summarize. So we can actually take a lot of this, put it in there. But the first thing we need is to also add a second string here, which is the summary prompt. And this one, I have it in my memory because I didn't want to remember that one. So here we go. Also adding the new line. So now, instead of the system prompt, we're using the summary prompt. Instead of this user prompt, if we do this conversation text. For this one, for just the summary, so 1 or 2 words, we need far less tokens, so only 200. And we're actually going to give it a bit of creativity, so we're going to up this one to 0.8. And the result we need is just a string, so we can actually get rid of this, because it's just giving a string back, so just the content from the message. So just like that, we have our summaries in there as well. So let's have a look at the result of that. So here we go. There we are. So a new window, and now I can chat again, and now we actually get a summary of the conversation. It's a fairly basic one, so let's give it a bit more of a actual content question. What is responsible AI? And now it's coming up with an answer, as well as making the summary of the conversation, ethical AI. So far so good. So now we actually have all of the OpenAI interaction done, but I think we can do a bit more just to have some fun with it. So in order to do that, I created a second system prompt, and this one is a bit more fun, and it's also a bit more specific. So I'm actually going to adapt this now to be really all about responsible AI, because I think that's a super important topic. But I also want to have a bit of fun with it, because otherwise it becomes a really dry topic as well. So we are now instructing it to be a Gen Z responsible AI assistant, very Socratic, so it's constantly asking questions back rather than actually giving answers, and it's also very sarcastic and uses lots of slang. So let's give it a try here in the portal first. So it is going to give me some content about responsible AI, but it's also going to add lots of emoticons and lots of stuff that is really all about the persona. So it's already talking about Skynet, so then you know you're really on something here. So a bit more interesting. So let's adopt this, and as you can see, it's actually giving a very verbose answer. So it's putting all sorts of stuffs in there, which is really what we aim for. So let's go back to our app. Since it's just a string here, I can easily change this, rerun it, and now we've adopted our app to be actually really specific to the purpose that we want to build it for, and to be a bit more fun as well. Oh. Here we go. A new chat. And if I ask, it now will give me a similar answer. I'm actually running the website against GPT 3.5 Turbo rather than 4, which I was using in the portal. And as you can see, the answer is a bit different, but it also talks about Terminator. So again, kind of what you expect from someone who wants to be sarcastic about AI. And with that, I'm going to hand it back to Roland, because right now, as you saw, every time I open the app, it's pretending like it doesn't know anything and it doesn't know who I am or what I've been talking about. Yeah. So now we actually want to add some persistence to it.
Yeah, and that's where the Cosmos DB comes in. So we're going to introduce it as a data persistence layer to store our message history so we can resume chats and read them back and do all sorts of fun stuff with it, because that's what our clients expect, right? Because that we're introducing fun prompts for their engineering, for their enterprise chatbots. No, but this is great to show what the difference is and how you can get different responses here. Oh, we already changed the screen. I was looking there, so I was filling the void, but it was not necessary. And we already showed, I think, that when you refresh it, it's gone. I can show it again, but we're now on the right screen just to talk you through the Cosmos DB implementation. And apologies for the Newtonsoft in there. I think we should have used system text JSON, but just for the real .NET engineers in there that got mad looking at it, it does not really. It's not really that important. So if we look at the data models that we're using in our chatbot, we saw sessions and messages. And sessions are these collections of messages with a nice summary, which we can store and of course, can delete and update in our client. And those messages are, of course, the chat messages itself, one for your prompt and one for the system response. And if we look at the session, well, it's just a model. It's just a data object. It's not really that fancy or cutting edge. But there's a very important one in there for Cosmos DB, and that's in this case the session ID. If you see the session ID, it's commented as a partition key, and partition keys are very, very, very important to Cosmos DB. Cosmos DB is an amazing database offering you can, well, almost just use. With the only thing when implementing it, you have to think about is that partition key. Because your partition key will lead to your data being in logical partitions, and logical partitions are a way of telling Cosmos DB how data is related. So everything in the same logical partition is somewhat close at a single location to make it easy. And that just makes it a lot cheaper to query, because Cosmos DB uses a kind of currency, request units, the RUs. If you're going to use Cosmos DB or have used Cosmos DB, well, you definitely run into the RUs, the request units. And one request unit will allow you to request 1 kilobyte in one location. So you can imagine if you store it in multiple logical partitions, you will have to query multiple locations, so you will incur more costs. And it can get expensive if you run large queries on your Cosmos DB databases. And then, of course, we store some tokens used. We have a unique identifier for the session. Of course, it has a name. That is a nice summary that Eduard just showed us. And of course, it has messages. And you see the JSON ignore attribute. That's why the Newtonsoft was in there. We're not going to serialize the messages when storing it in our Cosmos DB. So we only want the session object without the messages, and the messages should be separate in separate documents. And here we have some possibilities to add messages and update messages as well in our session. And the message is not really different. Of course, we also have the partition key, and since they all belong to the same session, and naming is hard because this is a different session than Eduard was talking about. So for our, these are the session IDs, just GUIDs for our sessions we are using here. And of course, these messages have unique IDs as well, which is also good, which we are setting in the constructor. So if we scroll down a bit, we see the constructor, and we see the GUID being set when we construct this message. But the important thing is we're using the same partition key. And of course, we need to implement this. We need to implement the data persistence. Because for now, we have just an empty shell. The constructor doesn't do anything. And we have some nice task delays for our actual work. So we have to do something about that. And it will definitely not making you watch me type code, but I can make you watch adding packages. See, there's the first typo. That's not why I'm not live typing here, except for this one. And I'm even going to copy this one, because typing is hard. And I'm having a huge constraint here, not shouting out developers, developers, developers every time I get to say something. So we add the Cosmos library, the NuGet library, and we also add the Fluent one, because we want to use the nice Fluent builder for building our client. Because also for this one, for the Cosmos DB implementation, we are getting a client that does the heavy lifting, that does all the work for us. But for this one, it's a Cosmos DB client. So to make it really easy, I just have snippets. So I have a constructor here, because you really don't want to see me type this out. But I will take you through it, because we have some nice null reference checking, of course, going on. And I will show you in a bit where these parameters are coming from in the constructor, because these are coming from dependency injection from our application settings. Then we have a nice naming policy we can set, so we get nice naming of lowercase property names in our Cosmos DB. We really love those, and data people especially love those. And then we get that client, that Cosmos DB client we were just talking about. We get a client, we get to construct it using a nice Fluent syntax. So we have the Cosmos client builder with the serializer options we mentioned above for the property naming, and we just build it, and then we have that client. And that client we can use, so we can use it to get our database and get our container. And this is, of course, another Docker container. And again, naming is hard. This is a container we store our documents in our Cosmos DB databases. And if we don't have a container, we immediately throw an argument exception. What are you doing? You don't have an existing container. Well, thankfully, we do. So we can move along to the inserting things. Because, of course, for the data persistence, we have to insert those messages. And again, not going to make you watch type, but click. So we can insert a session, and we can insert, make it pretty again, we can insert sessions and messages. And there's nothing, it's really straightforward. We're just creating items based on our sessions and messages. Those are the objects we were just looking at, and those are the things we are creating in our Cosmos DB. And of course, the most important thing is the partition key, is here the partition key. Because again, naming is hard. And then we have to get stuff as well, because if you click a message session, if you click a session on the left, we have to load in those messages. So we have code for that as well. And that is somewhat more complex, so don't be scared. It's really easy. And the first thing you notice is on line 55 and 71, it's something that really looks like SQL queries. And well, there they are, in fact, SQL queries. We're just not using a relational SQL database. We're using Cosmos DB, which has multiple APIs we can use to query our data. You are encouraged to use the same API as you're storing your data with, because when creating a Cosmos DB instance, you have to specify which API you are probably going to use. So whether that's Cassandra or Gremlin or MongoDB or just the NoSQL one, the generic one, it saves you a lot of request units to use the same API to request the data, because it does something to your underlying data storage. You can use all, but please do not. But we can still use those SQL queries, just the things you're familiar with, and that makes Cosmos DB so powerful, because for every data layer you're coming from, there's one way to get it into Cosmos DB. And of course, you have to rewrite some code, but a lot can remain the same. Well, for our get sessions, we of course use the parameter type sessions, and for our messages, we use the parameter type message, and we use the session ID to retrieve those items. We get a nice item query iterator, so we get something that returns us a feed. We can iterate over, and it does so retrieving it in a very nice asynchronous way, which helps with our Blazor front end, because that really does not like blocking, thread blocking operations. So we've inserted, we've retrieved our data, but of course we also have to update the data, so we have code for that as well, which is kind of similar. We need to update the sessions because Eduard implemented very nice technology to create a summary. But sometimes you maybe want to change that summary because you do not agree with it, or it will help you to find chat sessions more easily. So we have to be able to update the session. So that's the update session async. And we have to be able to add our messages to our sessions, and we're using upsert for that. And that's the only reason why we're using that, because we really want to show you can upsert items, and an upsert just does an update or insert. So if it doesn't exist, it will insert. If it does exist, based on that unique ID you provided with, it will just update the item, and it will always just succeed. And then, of course, because we always want to be able to remove our data, we have delete session as well. And that one is also pretty straightforward. It's a combination of everything we saw before, but then in line 129, we have a nice delete statement instead of an upsert statement. So now saving this. This is our code. So I think it's all pretty straightforward. Maybe if you've not worked with it, some things are new, but I think almost every developer should be able to understand what is going on. But then I promised to show you where those parameters are coming from, and those are, of course, set using dependency injection within our registration of services. So with our register service, we're adding a singleton for our Cosmos DB service. And we're using, on line 44, we're using the iOptions Cosmos DB, and that is coming from a couple of lines above it. Here, adding the options from our application settings and injecting those as well, so we can use them in our register services. So these are the values we're getting from the application settings, and that's why we're able to use them in our the constructor of our Cosmos DB service. And Eduard showed the same application settings, and of course sharing is caring. The keys here are not meant to share our OpenAI instances with you. I would love to, but I just can't afford it. So we'll delete those after, but they're up for the next couple of minutes. So if you really want to go wild, then please do so, but not make me go over my spending limit, because that will be a very awkward demo. And of course, we have to get those keys. So this is the Azure portal. Of course, we've shown the Azure portal for the playground. So I have a Cosmos DB instance here running to get my keys from. Just to get you started when you're going to do your lab, if you scroll down a bit, we have keys, and I think I have to zoom in a bit just to show you. And the things we're putting in there, it's the endpoint we're getting here and one of the keys here. So we can copy-paste this. I will not copy-paste both of them. I will just insert another snippet. The Cosmos part, and again, this nice key. Make it pretty again. So this is everything we need to wire up our chatbot and do the data persistence there. I'm now going to also copy in my prompt. And of course, I have to run it. So we do .NET run. Fingers crossed. It builds, so I'm happy here. And do a reload. Oh. Do a real reload. And it works. OK. Well, there's still no chats available, of course, because that is the problem we were facing just now. There was no persistence of message history and messages. So we can create a new chat, and I will paste the prompt I just created. And my bot is really mean, because I have another message I'm going to add in just a bit. And in like 50%, it will kick the safeguards, that it will activate the safeguards, and it will say, well, that's not very nice to say, but he didn't really say it, so it's not that bad. But what I wanted to try to show you, of course, is we can now reload our page, and it's still there. And we can add messages as well, so we have the other prompt, because, of course, we also know what Kermit would say about Statler. And Kermit is also not very funny in chatbot. Thankfully, it does give a reaction this time, but then it's not very funny one. But also, this is also persisted, of course, and we can see that in the portal as well. Oh, the portal is next to that. And we click back to, we zoom out just a little bit to click to our Data Explorer. So I'm now in my Cosmos DB instance, in my Data Explorer, so I can see what is in my Cosmos DB database. And I have that container, that chat container that I configured in the application settings, and there are items there. Vault is in, and this one as well. Make this a little bit bigger. So now we see here the sessions and messages being persisted in our Cosmos DB. So the top one is a session. So we also see the name here. Aha, that's a good one, Statler. No, I'm not very satisfied with that description, with that summary, so I can change it here, just into Muppet joke. I'm not that creative. My temperature is very low. So if we go back to the Data Explorer this time, and we refresh that one, we see it reflected in my Cosmos database. So it actually works. And this is, of course, a session, and we have those messages going from user to assistant, that is the sender there, and persisting our data with everything we do. And of course, just to show the last one, and then we get to the very fun part of bringing your own data. If we delete it, we also, this is the third time I'm making that mistake, we also see it deleted from our Cosmos DB. So our code actually works. But now, for the moment you've all been waiting for, bringing your own data.
Yeah, is this the moment? No.
This is the moment. This is, oh no, not going to sing.
If we then switch back to the other machine somewhere. Yeah. All right. So as we said, right now we have a website. We have persistence of the website. We have some prompts that we played around with. But usually, when I talk to customers, what they really want is to be able to unlock that whole host of documents that are out there, that are in the enterprises, in SharePoint, in blob storages, and whatnot. So that's what I'm going to briefly show here. We don't have it integrated into the web app yet, so there's some work to be done. But when I have this prompt again, so I'm still my Gen Z responsible AI assistant, I can click here to add your own data, and what I've done is I have a search index in Azure AI Search that I've put in our Microsoft Responsible AI Practices documents. So this is a bunch of PowerPoints and a bunch of PDFs that explain the way we think all of our product teams should be going about their responsible AI work. Those are public, so I'm not sharing any private information. But when I add it here, and I now start a chat, go into those documents, pull out the relevant snippets of information from it, inject that into the prompt, and then use that to generate the final answer. So that is the by now pretty commonly known RAG pattern, so retrieval augmented generation. So retrieval from search, bringing that into the prompt, and then using that to generate an answer. So let me actually make this a bit bigger. So here, can we go full screen? There we go. So when I now ask the question, I actually get some references with content. If I click on those, I actually see the underlying document. And it's now using that with the tone of voice, with the persona that I created, to actually answer the questions that I wanted to answer. So this is really kind of the most common first scenario that most of our customers are going through when they start adopting OpenAI. And now we have a simple web front end, persisted session, so you can actually have back and forth and come back later. a persona that we decide on what it should be, and then our documentation behind it so that it actually makes sense when it's answering. It's actually grounding the responses on actual documents from our enterprise and from our business. So that brings us to the final pieces. When you go through this on your own, there is a Azure deployment that you might do, so make sure to clean that up because there's a website, a Cosmos instance that are being charged. The Cosmos is usually a free one, but then still it's always good to clean that up. So don't forget to do that. It's quite easy, just throw away the resource group. And so let's wrap it up. So we've went through what it takes to deploy this whole solution. So a web app, a Cosmos DB, if necessary, a OpenAI instance. We've then looked at the front end that was already built, so Blazor app, and of course it's quite easy to replace that with some other technology to build front ends. We've connected the OpenAI instance, we played around with the prompts and with the parameters, then we added Cosmos DB to it so that we have persistent storage at a global scale. So with Cosmos, it doesn't matter if you have one user or a couple of million, it will scale towards that. And then we cleaned it up after a quick demo of using your data into it. One question that we kind of anticipated, but we don't have a room where we can get questions, is that how do you secure this? Because this front end that we now deployed will be open initially. And that's the beauty of Azure, because in the web app, it's a single checkbox to put an app registration in front, to have AAD-based authentication automatically, single sign-on that works.
Entra.
Sorry?
Entra.
Entra, sorry, not AAD anymore. My bad. And so even with one click, you can have a fully secured within your organization web app running. People can come in, ask questions, do whatever they want. Now, if you want to do this yourself, go to this address or use this QR code, because this is a module that is out there. The code is out there, both without implementation and with implementation, so you can actually build this yourself. As Roland was saying, if you have some spare time during Christmas, or if you want to impress your friends or family, that's also an option. I also want to call out this one. We have a lot of resources in our documentation and in our learning platforms for getting started with AI, and with generative AI in particular. And with that, we are finished. I think
right on time.
Yeah.
Oh, amazing.
So we don't have mics for questions, but if you do want to ask questions, feel free to come up, and otherwise, enjoy your lunch.
Have a great rest of Ignite.